Suppose the heights of a simple random sample of 100 male sophomores were measured rather than 625. Which of the following statements is true?
I said A.
Why?
I actually just redid the problem.
Yeah. But we know that.
If your sample size goes down, your margin of error increases.
Right, because our variance goes up, right? Our bell curve gets fatter and fatter. So if we actually did it out and change this to 100, our M would be 0.73. So that's considerably different from 0.29. It's a lot larger. How are we doing on time? What time is it?
It's 1:11.
Okay, good. We're almost done. We're almost there. Okay. So the rest of the questions are more conceptual, except for 34 and 35. So, 32. In the last mayoral election in a large city, 65% of the adults over the age of 65 voted Democrat. A researcher wishes to determine if the proportion of adults over the age of 65 in the city who plan to vote Democrat in the next mayoral election has changed. Let P represent the proportion of the population of all adults over the age of 65 in the city who plan to vote Democrat in the next mayoral election. In terms of P, the researcher should test which of the following null and alternative hypotheses. So A, the null, so that the P is the same, and the alternative is that P is less than 0.65. So this is one-sided with less than 0.65. The alternative where P is not equal to 0.65, or that P is greater than 0.65. So do we have any clues here that they want to know a particular direction that the proportion has changed?
Over the age of 65, they said?
Well, no, it's how they voted.
B is the answer, right?
B is the answer because
It's like obvious.
they don't care. They don't care whether the proportion has changed and has gotten less or the proportion has changed and has increased. They just want to know if there's any change. So we don't care about the tail. We just want to know if there's a difference, if the probability is different than 0.65. So our answer is B. Okay. So the tail area above a test statistic value of z equals 1.82 is 0.035. Determine which of the following statements is true or false. I think this question would be helpful to draw a normal distribution. Okay. If the alternative hypothesis is of the form that HA, where mu is greater than mu naught, the data are statistically significant at the significance level alpha equals 0.05. Tell me what to do with this. So someone decode what this means for me. What does this say?
The alternative hypothesis, or the mean of the alternative hypothesis is greater than the null.
And so if the alternative hypothesis are the data are statistically significant at significance level alpha equals 0.05. True or false?
Is that true?
Why?
I can't.
3.5 is
So we're
less
looking
than
for
5.
95% confidence?
Yeah. 0.035
It's less than.
is less than 0.05. Therefore, in a one-tailed test, where mu is greater than, right?
In a one-tailed test.
It's one tail to this side, right? But if we drew this way, z would be negative 0.182, and p would equal 0.035 as well. So either way, if we stated it this way or this way, and I think
C.
C is equal to or not, right? So B, let's do B. B is also true because this is still less than 0.1, right? And here we're only concerned with the one-sided test. Does that make sense? Because it's giving us the direction, right? This is direction. It only cares if it's greater than. It doesn't care if it's less than. It doesn't care about this. It only cares about this. We're only concerned with this tail, and we only care that p should be less than 0.05, and it is, and it's also less than 0.1. So A and B are true. But in C, our alternate hypothesis now has to do with,
But that's true too, right?
this is now a two-tailed test, right?
Oh, it's two. Okay. Oh,
So we have to add our probabilities.
oh, that's
So 0.035 plus 0.035 equals 0.07.
so that's not true then.
So is this significant at the 0.05 level?
No.
No. So we don't reject the null. We fail to reject the null.
So and D is true then.
So C is false, but D at the alpha equals 0.01 level, we do reject the null. So it's really important to know three directions. So anytime you have this directionality, you know it's one-tailed. Anytime you don't care about direction, it's two-tailed. Does this make sense? I'm sure you're going to have lots of questions on your exam about this. And I know we didn't have a chance to do a quiz or have a lot of time to do practice problems. So if you have any questions, let's review them. Anything?
I guess I'm kind of just confused on C, because I understand, 0.035 is smaller than
0.05?
0.5, so then that's true. And the same for B. And then C, I understand that because it's two-tailed, that you would square it.
You would double
Or
it. You would
double it.
add it.
Okay, I'm sorry, yeah.
Does that
You
make
would add
sense?
it, right? And then it would, what was the answer when you added it? It was like 0.7?
Yeah.
And we said it was
0.07.
And then we said it was false because...
0.07 is greater than 0.05.
But it's not a direction. It's saying that it's not equal to... I guess I'm saying...
Exactly. Okay, so when we're given z equals 1.82, which has a probability associated with it of 0.035, we're told the tails. We're told about the tails. So in this case, z equals 1.82, and it says the tail above a test statistic. So we're told the tail above the test statistic. And we know that 1.82 is going to be somewhere over here on our curve, right?
Mm-hmm.
And we're told the probability for this is this. We know by the rules of a normal distribution that there's symmetry. So at negative 1.82, the probability of this tail is also the same thing. For questions A and B, we're concerned with this side, right?
Right.
Whether mu is greater than the alternative. And given the probability of 0.035, we can say yes, it is. Reject the null. And with B, it's the same, because it's still less than 0.1. With C, however, we're now asked about a two-sided hypothesis, two-tail. So we have to consider the probability of the right side of the tail and the probability of the left side of the tail. So we have to add these two tails. So P equals 0.035 plus 0.035 equals 0.07. So in a two-tailed test, we do not reject the null because P is greater than 0.05. But when our alpha is set at 0.1, we do reject the null because our P is less than 0.1. Does that make sense? So for 33, it would be true, true, false, true.
Okay.
So the survey of study habits, so I'm going to move on, is that okay? Any more
Yeah.
questions? Okay. The survey of study habits and attitudes is a psychological test that measures the motivation, attitude, and study habits of college students. Scores range from 0 to 200 and follow approximately a normal distribution with mean 110 and standard deviation 25. You suspect that incoming freshmen at your school have a mean mu, which is different from 110, because they are often excited and yet anxious about entering college. To test your suspicion, you decide to test the hypothesis that mu is equal to, the null is mu equals to 110, versus alternative that mu is not equal to 110. You give the SSHA to 25 incoming freshmen and find their mean score to be 105. What is the value of the test statistic? So Z equals to something, right? Where is equal to, right?
How did you know to use that information?
Because we're sampling a population of 25 based on an already established population, right?
It's not already established. Right?
We've already established that the mean equals 110 and the standard deviation is 25, right? We're just trying to test whether if we randomly select 25 students, that
Sigma.